Okay, so we're on Geometry Unit 7 Assessment Review. We're on question number 1. In question number 1, they tell us that triangle ABC is an isosceles triangle. So right away I know that these sides are congruent. They even tell me that AB is congruent to BC. And they tell me that median BD in green here, okay? And I have a median here. And they tell me that the perimeter is 96 and that from A to D is 10. Well, first of all, I know it's isosceles, so I know that these two sides are congruent. I know that this is a median, means that it's bisecting segment AC, so that this side here is 10. Well then, this is the median here, and this side is also here, what is 10? So the whole thing, this whole side here, side AC, is 20. But I know that the perimeter, if I add up all the sides together, they add up to 96. Well, the whole thing is 96, but I've used up 20 units, so 90 minus 20 leaves me with 76 units. Well, I know that these two sides are congruent because it's an isosceles triangle. So I have to take 76 and divide it by 2. This 70, all of the 76 go a little bit here and a little bit there equally because they're the same. So 76 divided by 2 is 38. So the answer is 38. What is AB? Is 38, which is letter A. Let's move on to question number 3. If we look at question number 3, they tell me I have a spa circle here, I have a deck in wood there, and they want to know what is the perimeter of the deck, right? Well, the first thing you need to remember, is that they give you the radius of the circle. The radius is from the center to the circumference is 3.25 feet. But if I have a radius to the other end of the circle, that's also going to be what? 3.25 feet. So really, the diameter of this entire circle is 6.5 feet. But the thing you need to notice is that the diameter of this circle is also the same length as the deck, which is out here. So this circle has a radius of 3.25, but it has a diameter of 6.5, and the diameter goes from one end of the circle to the other end. Well, isn't that what the side of the deck goes here as well? It goes from one side to the other side. So these are congruent. So if this is 6.5, then this is also going to be what? 6.5. And so is this side here, also 6.5. And since the radius is always the same, then this side is also here going to be 6.5. I can have another diameter going like this way, right? Which is also going to be 6.5 units long, because that's the diameter. And this will also be 6.5, and this will also be 6.5. So basically, I got 6.5 4 times. So if I add up all the sides, 6.5 times 4, I get 26 feet, which is letter D. Let's take a look at question number 5. Question number 5, I have a custom glass tabletop, right? They tell me that the apothem, the distance from here to here, is a 1.2. And they tell me that all the sides, all the bases are 1. So this is 1, this is also 1 here. They're all 1s, right? And they want to know what the area of the entire octagon is. Unfortunately, there's no formula for the area of an octagon. However, I do know that I can make a triangle here, and I do know how to find the area of a triangle. I know that the area of a triangle is equal to half the base times the height. Well, let's take a look here. They gave me the base of the triangle because all of the sides are 1. They told me that. It's a regular polygon, so this is 1. And they gave me the height, which is the apothem, which is 1.2 meters. So I have everything I need to find the area of this little triangle here. Well, area is equal to 1/2 base times height. So the area is equal to 1/2 base, which is 1, times the height of 1.2, and the area is 0.6. So the area of this little triangle right here is 0.6. But the thing is, how many of these triangles could I make here? Well, I could make another one. 1, 2, 3, 4, 5, 6, 7, and 8. Right? 1, 2, 3, 4, 5, 6, 7, 8. And they would all be congruent. And they would all have areas of 0.6. So that means that I would have 0.6, 1, 2, 3, 4, 5, 6, 7, 8 times. So 0.6 times 8 is 4.8 meters squared. So the entire area of this octagon here is 4.8 meters. So I made a little triangle here using the base and the apothem as the height. I found the area of the triangle, and then I multiply that area times the number of triangles that I would have in my octagon, which is 8, and the answer is 4.8, which, by the way, is choice B. Number 7 was a little tricky, and you had to know a little something about area, and you also had to draw the picture. If you didn't draw the picture, you were in trouble in this question here. So first things first. They tell me that I have a square with an area of 64 square centimeters. Well, if I have a square that has an area of 64, then I know that the sides are going to be 8, because 8 times 8 is 64, so I had to draw that out. Then they tell me that square with an area was increased, that they increased the length but not the width. So I made up my own little square here. By the way, let me take this off. Okay, so I took my square and I increased the length but not the width, meaning the width stayed the same, so that's 8 and 8. But then when I added the perimeter, it was going to be twice as big. Well, first of all, what's the perimeter of this little box here? If the area is 64, 8 times 8, 64 comes from 8 times 8, the perimeter is 32. Add up 8 plus 8 plus 8 plus 8. So when I extended my sides, the perimeter was going to be twice as big. Well, the 32 twice as big is what? Is 64. So the perimeter of this new shape here would have to be 64. Well, I know that this is 8 and this is 8. 8 and 8 is 16, right? But when I add up all the sides, they're supposed to add up to how much? To 64. So 64 minus 16 is 48. So then, I know then that if I have 48 to divvy up between these two sides, well, this side's going to be 24, and this side's also going to be 24. Look, if you got this question wrong, don't feel bad. They didn't give you a picture. But the only way that you're going to get this question right is if you draw the original picture and then try to draw the new picture sticking to the information that they give you. That's the only way to do it. And the more you see of these, the more experience you'll get and the better you'll be at it. But you got to practice them. So then I know that the new perimeter was 64. 8 and 8 is 16. So 64 minus 16 gives me 48. So I know these two sides are going to be 24. Well, now that I know that this is 24, can I find the area of this one here? Sure. 8 times 24 is 192. So the area of this new image here is 192 units squared. But you gotta answer the question. The question was not asking you, what's the area of the new quadrilateral? The question is asking you, by how many square centimeters did the area of the figure increase? So if it was 64 centimeters squared, and now it's 192, the question is, by how much did it get bigger? Not what size is it, by how much did it get bigger? Well, if before it was 64, and now it's 92, 192 minus 64 is 128. So it got bigger by 128 centimeters squared. Again, I would definitely recommend that you look at this question again and that you try to draw this picture again on your own and try to do it so that you can figure out, because there will definitely be a question like that on the EOC. Let's move on to the next question. Question number 8. They gave us the picture of a parking lot. Okay? They gave us a picture of a parking lot. And if you notice here, what I have is I have a parallelogram. And I have one of the sides of the parallelogram, which I can call the base. And this right here, guys, is the height. This is the height of my parallelogram. And really, a parallelogram is a quadrilateral, right? It's a quadrilateral. So how do I find the area of a quadrilateral? The area of a quadrilateral is equal to the base times the height. Area is equal to base times height. So the area of this quadrilateral, the space inside, would be the base, which is the stall width, times the height. But here's the thing. In this question, they told me, right here, they tell me that the area of each parking stall is going to be what? It's going to be 135 feet squared. And they also tell me that the stall depth, which is the height, is how big? 18. What they want to know is, what's the width? Think about that for a second. This is a quadrilateral, right? I know the formula for the area of quadrilateral. Area is equal to base times height. They're giving me the area, they're giving me the answer, and they're giving me the height. right? There's the height right there, 18. And remember that the height is always perpendicular with the base of any quadrilateral, right? That's how you know it's the height. Because the height is perpendicular with the base, and the base is perpendicular with the height. Okay? Well, take a look here. They gave me the area. The area is equal to what? 135 feet squared times the base, which I don't know, times the height. So it's 135 is equal to b times 18, or I could just say 135 is equal to 18b, right? Because algebraically, that's probably how it should be. Well, these are being multiplied. I want to find the base. What do? Divide both sides by 18. 135 divided by 18 is 7.5. This cancels out, gives me 1b. So b is equal to 7.5 feet. The base of this quadrilateral here is 7.5 feet. They gave me the area, right? They gave me the area, the space inside. They gave me the height. They just wanted the base. And we've solved it here. Area is equal to base times height for any quadrilateral. Just plugged it in and solved it algebraically. And the last question. We have a basketball court. You're definitely going to see one of these. We got a basketball court. They want to know how much paint would be needed to paint this entire basketball court here, right? Well, I know that this part of the court is 12 feet by 19 feet, right? So I can find the area of this quadrilateral here. Well, area is equal to what? Base times height. 19 times 12, which gives me 228 feet squared. So this part right here is 228 feet. But I also got to paint the top of the key, right? Well, if you notice, that's half a circle, right? Isn't that a half a circle? Then if this side is 12, if this side is 12, then this side is also 12. The diameter of this circle is also 12, which means that the radius is 6. Well, don't I have a formula for the area of a circle? Sure I do. There it is. Area of a circle is equal to pi r squared. And I know that this side is 12. This side is 12. So the radius from the center to the edge is 6. So the area is equal to pi times 6 squared, which is, by the way, 6 squared is 36. So it's 3.14 times 36. So the area of the entire circle is what? Is 113.04. That's for the area of a circle. But this is not a whole circle. It's only half a circle, which means that this 113 needs to be divided by 2. So the area of the key up here is 56.52. Okay, the area of a circle is for the area of an entire circle. This is not a whole circle. This is what? This is half of a circle. So I got to divide the answer there by 2. So the quadrilateral is 228 feet squared. This part of the key here is 56.52. I add those two together, 228 plus 56.52, and the answer is 284.52. Now, some of you guys put that on the test, and I still give you credit for it, but on the test, they'd probably give it to you wrong, because what does it say here in bold letters? Right here, it says, to the nearest whole square foot, which means that they wanted you to round to the nearest square foot, which is 285 feet. So I didn't mark it wrong. I probably should have, but I didn't. But just be aware of that the answer would be 285. So you add the area of the quadrilateral, the area of the half a circle, and you get 285 feet.